Since the dawn of time, humans have looked up at the stars and wondered what secrets they hold. Among them, none are as mysterious or as terrifying as black holes. They are invisible monsters of gravity, born from dying stars, yet capable of reshaping entire galaxies. But where do they come from? And if nothing can escape them, not even light, how do we know they're really there? Every black hole begins with a star. A star is a colossal nuclear engine, mostly made of hydrogen, burning fiercely in space. For billions of years, it balances two powerful forces: gravity pulling inward and nuclear fusion pushing outward. But this balance can't last forever. When the star runs out of fuel, fusion slows and gravity wins. The outer layers collapse inward at unimaginable speed. In the blink of an eye, boom, a supernova erupts. The explosion is so powerful it can outshine an entire galaxy for a few weeks. What remains afterward depends on the size of the original star. A smaller one might leave behind a neutron star, a dense core packed tighter than anything we can imagine. But if the star was truly massive, more than 3 times the mass of our Sun, gravity crushes everything into a single infinite point. A black hole is born. So what exactly is a black hole? Imagine gravity so intense that even light, the fastest thing in the universe, cannot escape it. The boundary of that region is called the event horizon, the surface of the black hole. Anything that crosses it, a planet, a spaceship, even light itself, can never return. To an outside observer, anything falling toward the event horizon appears to slow down, freeze, and fade into blackness. But from the falling object's point of view, time continues normally, straight into the unknown. It's a one-way ticket to somewhere physics can't yet explain. At the very center lies what scientists call a singularity, a place where gravity crushes matter into infinite density. Here, the known laws of physics break down completely. Einstein's theory of relativity predicts it, but quantum physics, the science of the very small, refuses to agree. This clash between the two greatest theories in science is one of the biggest unsolved mysteries in physics today. Some believe singularities might not be real points, but gateways, perhaps to other universes or distant regions of spacetime. Others think the singularity is an illusion, that quantum effects smear out the collapse before it ever reaches infinity. Right now, no one knows for sure. For decades, black holes were just mathematical ideas, elegant but unproven. Then came the evidence. In 1971, astronomers discovered Cygnus X1, the first strong black hole candidate, swallowing a nearby star and emitting powerful X-rays. Later, the Event Horizon Telescope captured the first ever image of a black hole's shadow in 2019, a glowing ring of light around darkness. And in 2015, the LIGO Observatory detected gravitational waves, ripples in spacetime, from 2 black holes colliding. Each discovery confirmed black holes are not just theory, they are real cosmic engines. Not all black holes are the same. Some are small, just a few times heavier than the Sun. Others are supermassive, millions or even billions of times more massive, sitting quietly at the centers of galaxies. Our own Milky Way has one, Sagittarius A star, about 4 million solar masses wide. There may even be intermediate black holes, rare, mysterious objects bridging the gap between stellar and supermassive ones. And some scientists suspect primordial black holes formed moments after the Big Bang, tiny, ancient relics of the early universe. It's a question that fascinates and horrifies at once. What would happen if you fell into a black hole? First, you'd feel the pull of gravity stretching you. Gently at first, then violently. Your feet would feel a stronger force than your head. Scientists call this spaghettification, being stretched into a long, thin strand of atoms. For small black holes, it happens instantly. For supermassive ones, you might drift inward for hours. seeing the universe outside speed up like a time-lapse movie. It's a trip you wouldn't survive, but one that reveals how deeply black holes warp space and time themselves. You might think black holes live forever, but even these cosmic giants have an ending. In 1974, physicist Stephen Hawking made a shocking prediction. He showed that black holes slowly evaporate over time, releasing tiny particles of energy, now called Hawking radiation. For massive black holes, this process is extremely slow. It could take more than a Google years, that's a 1 followed by 100 zeros, for one to vanish. But when the final moment comes, the black hole releases all its remaining energy in one last spectacular burst, brighter than millions of suns. Black holes are nature's greatest paradox, where creation and destruction meet, where time and space lose meaning. They teach us that the universe is far stranger than our minds can easily grasp. And yet, they might also hold the keys to understanding everything, from the origin of the universe to the limits of reality itself. In the end, black holes remind us of something profound. The closer we look into the darkness, the more light we find in our curiosity.